Did I get some sleep? You mean since yesterday,
Did I get some?
or what? I didn't get sleep today, but I had a pretty good night's sleep last night. How's the refactor going? Well, most of the last stream was explanation and question answering, and a little bit of profiling. And then we looked at, uh, well, then I deleted the complicated part of the old polymorphism system. And this stream, we're going to try and do a better one. But first, I'm going to get a cold drink. It's very hot in here. The weather outside is super nice, which makes me wonder why I'm stupid enough to be a programmer who's indoors all the time. Yeah. So I'm going to get some iced tea. I'm going to get my cough drops, and we'll start in a few minutes. You were just implementing SLAM. Yeah. So my understanding of SLAM is that it's really hard, or maybe nobody has ever made it work correctly at a high level of robustness, which is why these VR systems don't use inside-out tracking. But I don't know. I mean, neural networks are really good lately, so maybe you could apply neural networks to doing high quality SLAM or something. I don't know. But it's not a topic that I know anything about. Now I'm going to have to remember to get my drinks out of the freezer within a couple hours, or I will be very sorry. How do I know about him? People just said, hey, host this guy. And I looked and he was working on an interesting problem, so I did. Okay, we'll start in a about 2 minutes. It's really hot in here. If I open more windows, it might get loud. Let me turn on the air conditioning. Someone is asking, would I suggest avoiding object-oriented programming with C++? Yes, I would suggest that. Any recent video games or ones on the horizon I can recommend? I don't know. I mean, Opus Magnum was good. That's the most recent game that I played really intensely, unless I'm forgetting something since then, which I may well be. I have a I have a Steam page where I recommend games, right? So if you search for my curation group on Steam, then you can see what I recommend, and you can click View All. And I don't know why that's not showing all the games. I just said View All because it's frickin' Steam and it doesn't work simultaneously because it's Steam and because it's a web page. Maybe you have to be logged in. Oh good, I got Steam guarded. Thanks Steam for Steam guarding me. If you have to be logged in, the least they could do is say you got to be logged in. All right, let's see what happens. View all. Nope. View all. Yes. Okay, so one view all button does not work, but the other one does because it is the World Wide Web. Gorogoa is good. Opus Magnum, Fidel Dungeon Rescue, Shenzhen IO, Glittermint Grove, Inside, Pony Island, Steven Sausage Roll, Space Giraffe, Snakebird, TIS 100, Infinifactory, English Country Tune, The Swapper, VVVVVV, etc. I have many fine games that you could play if you were so motivated. Okay, so, you know, I should play Crypt of the Necrodancer again sometime. Because I never, like when I played, they still hadn't added everything to the game. It was like super early access action. So I could give it a try. Not now because we're programming, but later. Twilight Struggle, see what all the board game guys are nuts about. Sure. Okay. Well, it's been more than 2 minutes. So, in the last stream, we broke polymorphism by deleting all the complicated stuff that I didn't like. Not even necessarily all of it, but enough of it to do the damage. And so now, if we try to compile this program, oh, that's Sokoban. If we try to compile even this simpler test program right here, it will no longer work. And the error message isn't really telling you why, because the compiler is confused about what I just did, but it's basically, we can't handle any more polymorphism at a depth more than 1. So this works because the polymorphic procedure is right here at top level, but this doesn't work. Because the polymorphic variable is inside a procedure, and procedures are kind of their own thing, and as far as polymorphism goes, they have their own constants block, and That would also be true for a struct, right? It also wouldn't work. But we're going to do the procedure part first. Have you played Pony Island Guitar Freak all the way through? I don't think you have. I don't think you have. Okay. Now, let's talk about what I am going to do, and I'll think my way. I've already thought my way through vaguely how I'm going to do this, but maybe we can make it more concrete. The way that pattern matching works is, well, before we had polymorphism, we already had a type checker, and we had this routine called check that types match, right? And if your types are not polymorphic, where'd it go? What? Why am I freaking out right now? Is it in a different file now? Oh no, we're missing half the file because frickin' Emacs. No, maybe not. No, it is there. Emacs just likes to delete files sometimes because that's the level that it has sunk to. Or delete portions of files. So if I search for : check that types match, here we go. So we call this thing, and here's the main. The other ones are like entry points. And this thing just looks at your types. So like if one of them is a pointer to something and the other one is a pointer to something, let's recurse and check that what they're a pointer to is the same, right? If one of them is a function with some arguments and the other one is a function with some arguments, we'll first make sure the number of arguments is compatible and then recurse on each argument and make sure the types match. That's how we do this, right? So in order to type check, you already have to almost do pattern matching. The only thing we added to that was, oh, sometimes you could encounter a variable that starts with $. And if you encounter that, then, well, just say that it matches and then assign that variable to the subtype, right? So that is how our polymorphism works. Now, the thing that makes it complicated is that in some cases, like this one, we cross boundaries from one polymorphic object, which is apply, into another one. How loud is that bus going by? Is it annoying or is it fine? Into another one here that has its own constants block. And so we need to do something special to make sure that this value ends up in this procedure, right? And not in the outer procedure. And the way that we did that before was with, a propagation of names up to the top level and then back down that I got really annoyed with. And so that's what we're doing, is we're replacing the way by which we cross boundaries correctly into the right polymorphic object. Okay, well, it annoys me. If the bus keeps annoying me, maybe I'll close the window. Okay, so that's the basics of what's going on. Now, when we do the pattern matching, we do it with this thing. I don't know where it's defined. It's called polymorph match, I think. Where is it? There we go. It's in polymorph.h. So we just say, well, there's an identifier and it's bound to some expression, right? And that's for a binding of one single variable that happens in that pattern matcher. Now, the way we get those, or the way we pass those to the rest of the program, is they're collected in an array in this thing called match status. And match status is just like the whole result for the polymorphism of the whole function. So if there's a variable called t, and a variable called r, and a variable called hello sailor, then you would end up with a match status with 3 matches in this array, and one of them would be for t, and one would be for r, and one would be for hello sailor, right? So that's all fine. And then there's a little bit of utility stuff. So this variable is active here in match status. I'm going to try just pointing with the eye tracker. I don't know how accurately it is, because I realize when I'm doing all this and eye tracking, it's probably a lot. But is active there, just in match status, is not really for anyone outside. It's a way that we tell the type matcher that yes, right now we are assigning polymorph variables, or no, we aren't. And then this new match is disabled due to processing subsequent varargs. It's a thing we just added a few streams ago to deal with type ofs, and that worked pretty well, and I'm happy with that. Okay, so are we all good with this so far? Do people get what I'm saying, basically? We have screens in our windows here. This is a civilized country. We are improving a compiler. If you want a really broad rundown on what we're doing, you can go to the video on demand page, wherever that is, the videos page, and look at the stream that happened this morning from like about 10 a.m. to 11:30 or something like that, where I explain in great detail what we're doing. This was just like a catch up and an advance a little bit more in the specifics. Okay, I don't see any other questions specifically about polymorphism. Go ahead and drop some in the chat if there are. So now the problem that we have, the reason this is not a hierarchical structure is because before we used to lift all the polymorphic variables up to the top level. And I don't want to do that anymore because I think that ended up messy. So instead, I want to push the values down to where they need to go. And that should not only be less messy, but it should make the compiler a little faster because we don't have to generate all these temporary polymorph structs. Although when we profiled, we realized maybe not as much faster as I had hoped. But then also, it's less complicated, I think. Because the old way had a bidirectional action. You had to do things going up and then do things going down. And here we only have to push things down. So I think that is superior. So someone is asking, so you want to allow methods, functions to be passed through parameters? No, we already could do that. That's worked forever. It's no problem. What we're trying to do is allow polymorphic methods or functions. There's no such thing as a method in this language. We're trying to allow polymorphic functions to be passed as parameters and for that to work. So the thing that's making this not work is the $t, right? So if I change this $t to an int, then this should work because, you know, we're calling this on an int, right? So, well, y has to be int also, right? There we go. So that works. There's no problem. Oh, this is a 0. Let's do 5. We always like 5 factorial for some reason. So it's 120, right? So that works fine. But the problem is now if I want a float, if I see b float equals 7, apply factorial b, this will not work because it's not polymorphic, right? So when we say polymorphic, we mean the equivalent of, for example, C++ templates or whatever, but the way we do it is a lot better than C++ templates, right? So here we want an int and we're given float, but that'll work fine if we do this. It's just that, oh, sorry, not this. If we do this, the problem is simply that this won't work now because we broke it this morning by deleting a bunch of code. Does the team refactor Sokoban with use of new features added to the compiler? Yeah, we use the game as generally a test that the features in the language really make sense and are really usable. Because sometimes you have an idea for how people could use something, but if you don't really test it, it might be more inconvenient or it might fail in certain cases. And the way that you know that for sure is by using it seriously. Have we made struct literals better already? No, we got to do that still, but that's less important because I don't think that contaminates the entire compiler with complexity because it's just one thing kind of off the edge. Whereas polymorphism affects so many things. So, yeah, it's not an object-oriented language for sure. This is a procedurally oriented language, data-oriented language. I don't know what you would call it. All right. So what we really need to do is, where was our declaration? It was in polymorph.h. I should have remembered that. Not polymorph.cpp, polymorph.h. Okay, so this polymorph match, no, not the polymorph match, the match status now needs to be hierarchical because it needs to have a set of variables for each polymorphic thing. So now there are multiple polymorphic things. And well, okay. Also, under normal circumstances, we will not need to do anything too fancy, right? Because, for example, we did our simple polymorphic routine here. In this routine, this already works. We don't need to do anything extra, right? So what we need to do on a match status is somehow add pointers to more match statuses that we could fill in if we need to. And I think the way that's going to work is that if we're currently inside a struct or procedure, those are the only two things that can be polymorphic and have a boundary to another polymorphic object in them. Then we'll just have, well, both of those have well-defined arguments, right? So a procedure has arguments and return values, but, you know, we'll combine both of those into one indexing, so we only have to have one array, and structs only have arguments. So here I can say, I don't know what to call it, sub argument polymorph statuses is, oh, this is wrong language. C++ is so weird after you've been programming other things. This is going to be an array of match statuses, and it's going to be null. It's an array of pointers to match statuses. Okay, so when we're type matching a procedure, so like I said, there's some values here that are just utility, right? So like This and this are here so that the type matcher can do its job a little better. So when we're going to add a utility that's like, which argument index are we processing? So, and I'm going to make that an S32 just to fit it in here. So we're going to say S32 current argument index, which is going to be -1. So when we are matching, as we go through each argument, we are going to increment that argument index. And if we are in a if we're in one of those arguments and it's a polymorphic struct or procedure, then we will allocate this array of argument polymorph statuses if it doesn't already exist. Then we will fill in a match status for whichever argument that needs to be, right? And the rest of them will be set to null. And then we'll use that new match status when we recurse down. Now, the other thing I'm going to do is I think I'm going to get rid of this is active. The way we're going to know that matching is active or not is just if the pointer is null or not. I think. Yeah, we'll say that. We'll say that. Any questions about that? People are talking about Java in the chat. All right, well, great. I'm glad you guys like Java. Oh, people don't like Java. Okay. If you want a summary, you can watch the previous VOD, which we give a really good explanation of what we're doing. It's at the beginning. How is it different from polymorphism in C++ templates? In a lot of ways. A lot of ways. The main, if you want to know the main fundamental difference, it's just that we don't really treat polymorphic things as being that different from anything else, right? We don't go like, oh my God, a template, right? A polymorphic function is just like anything else. It's just a function, it's just the argument happens to be polymorphic. And that leads to a greater fluidity and ease of use of polymorphic things. You have more power with polymorphics in this language as well than you have in C++. So, yeah. What's the reason for not having things like header file? Does anyone actually want header files? Like, why do you want a header file? Seriously. Well, then, if you're not saying you want them, then you know why I don't want them. I mean, we wouldn't be able to compile in 1 second with header files. Let's put it that way. All right. So I'm sure, you know, I need to make a video. We were talking about this last stream. I need to make a video clip version of the frequently asked questions, because all of these topics I've gone into sometimes for 10 minutes, sometimes for half an hour. And, you know, if I give an explanation now, it's probably not going to be as good as that explanation. So it's a legit question, like why do you not want header files? And I've answered that a few times before on video that's on YouTube. So it probably would be worth our time to go dig those out and find the best one and then link people to that. Applied doesn't work yet. No, that's what we're working on now. Yes, you could pass it a polymorphic function if you wanted, yes. Have I thought about how to document the language? No, we don't care right now. We'll document it eventually, but it's just not on the priority list. And when we roll new people onto being able to use the compiler, we're not really going to hand them a pile of annoying documentation. We're going to give them sample programs, and we'll have like video meetups where people can ask questions live, you know. How will the witness be preserved, let's say in 60 years? We don't know, because it's hard to predict the future. But we can preserve it because we have the source code and it relies on very few dependencies. So, yeah. Okay. So let's start doing this. So I'm going to delete the isActive, and that'll force me to deal with that. Now on the polymorph, we have these match statuses. So these are now going to be this. Okay, we're going to have an interesting time thinking about some things here. We are going to want to be able to do a thing called, we need to be able to say, expand match status, right? So we're going to make, you know, because when we open a new level in the hierarchy here, we're going to say expand match status in the wrong language. And int target argument. This is going to be the one that no, let's separate this out. So expand match status is just going to allocate the array. It's going to be trivial for now. And then we're going to need to be able to allocate a match status even when we're not going down levels, because we just turned these into pointers that point at null. So now the way that we activate polymorph matching is to allocate match statuses and put them here. So we're going to say match status, make match status. There we go. So and we're going to use this thing called typer new. I don't know which version we can use. So I might have to modify this in a bit, but we're going to say auto status is typer new match status and return status. It's pretty easy. You know, we don't want to allocate this, even though the type checker is not currently parallelized. At some point, we will want it to be able to run in parallel. And at that point, you know, we don't want to be trying to synchronize on a common memory allocation resource. So, you know, assuming that the typer itself is like one self-contained thing, where the parallelism boundary is outside it, then an allocation like this will not force a synchronize. That's why I have like pickiness about separate allocators, right? And it's also why all these languages that tell you that you don't have to worry about where your memory comes from are full of crap. That's one of the many reasons why those languages are full of crap. Okay. Void, polymorph, expand, match, status, in num arguments. So all these things are going to be kind of trivial right now, but the reason I'm making them actual routines is they may get more complicated later. Okay, so expand match status says auto mem equals, let's look at type or new. Oh, whatever. We're just going to use get memory on the interp. Even though I said we don't want to force synchronization. It's just like, well, we'll see that in the profile. We just need the ability to change it later, right? So let's use this. Because we want to get a number of bytes, and we don't have a version of that for the typer yet. Equals typer dot interp size of match status star num arguments. We're going to assert as greater than 0 because we don't. If it's 0 and we're calling expand, there's something wrong. We want to actually call this because we're making space for things. So we get that memory. Status arrow argument polymorph status is mem. We're going to assert that this was null. So we get the memory. I always do this. You know, and I realize there's like functions like calloc or whatever in the C standard library, but these things should not be, there's too much coupling, right? I want to set the memory separately from calling the allocator, if only because for debug purposes, I might want to set the memory to something besides 0. Mem set. Mem 0 num bytes. Okay. People say C++ is not object oriented, but come on. Look at the feature set. Come on. Come on. I do use classes, but I use very, very, very limited inheritance. Only single inheritance. Only a couple levels at most. And I certainly don't use RAII, which is like the worst part of C++. Yeah, I know he claims it's not, but yeah. What are the OOP features of C++ after 98? How about the fact that everything is based on all this stuff? So when the for loop, right? The new for loop wants to interface with iterators. How are iterators defined? As methods on classes, right? I mean, come on. Don't ask me stupid questions like that. Like, try to answer the question yourself honestly before trolling, right? Seriously. Why do you use inheritance instead of having a struct as part of another struct? Because you get the ability to call a procedure and have the downcast or upcast or sidecast, whatever you want to call it, happen automatically. So if I have a thing that's a subclass of entity, I can call a function that operates on an entity with that. That is really pretty much the only reason. I don't really use method overloading hardly ever, only in very rare cases. Is every statement legal to defer, even declarations? Yes. It would be weird to defer a declaration, but you could. Probably the code linter should probably look at that and say, that's kind of weird. But then there might be legit reasons, like maybe that declaration, because we do have constructors right now. I'm not sure if we will in the end, but maybe that declaration has a constructor on the type that you're declaring, and you just wanted that constructor to run for some stupid reason. I don't know. Does your defer macro not use RAII? People are confused. RAII is not a mechanism. It's a philosophy of how you should structure your code, right? Defer, the fact that defer runs things at scope close is only very vaguely related to RAII, right? RAII says you use that ability to do things at scope close in very specific ways, and it's bad to do other things than that, right? Do I still use the C array pair of pointer count sometimes, or do I always use your array class? Well, the templated array class that I use in C++, the main reason I use that is because it auto-expands, so I don't have to know how many elements there are. It turns out that's what I want most of the time. Very rarely do I not want that, but I do want that here, right? So for example, I'm about to do pointer length here because I realize when I'm making this memory, well, for debugging purposes, it's probably good if I record how many there are so that I make sure that I don't overflow dereference outside that, right? So I'll say status num this whole thing equals num arguments, right? So we'll do that. So this is a case, like if I know how many there are going to be, and I know that it's not going to change, then I'll do this. Did I just say that I use inheritance? Yes, I use a very limited small amount of inheritance. There's inheritance in this new language that I'm making, a very limited small amount. Sometimes tools are useful, right? If you go into this trying to like be tribal and like wear a tribe hat about like everything that an object-oriented language ever did is bad, that's not really going to get you to a good place, right? There are reasons why object-oriented languages are bad. You know the reasons, and then you do things that don't do those bad reasons, right? But to the extent that they do things that are useful, the small extent that object-oriented language do things that are useful, just adopt those, and that's how you make something successful. All right? You don't want to be weirdly, I mean, I realize it's human nature to do this, but you don't want to be weirdly tribal about technical decisions. Because technical decisions are reality-based. And the human tribal instinct is not about physical reality, it's about, you know, group survival due to social statuses or whatever, right? So if you want to be a good engineer, You need to know the difference between those two things. Don't be naysayer at everything. Okay, well, that's one way to put it. Someone says, the problem with criticizing OO is there are many kinds of OO programmers, and when you say OO is bad, a lot of them hear you're bad. Yeah, people do hear that, and that's a bad tactic if you're trying to convince somebody. At the same time, it is kind of true, though. Like, if you learn how to program within object-oriented dogma, and that's your only idea of how to structure a program, you're probably writing code that is a lot worse than you could write. And what makes you a bad programmer if not that? Okay, and this is why it's important to fix it. This is why it's not just a point of style or of arbitrary philosophy to like OO code or not like OO code. It makes you a better or worse programmer to program in certain ways. So whereas telling someone you are a bad programmer will make them mad, and that's not a good tactic for convincing them to be on your side, it's kind of true in a lot of cases, right? The web wouldn't be what it is today if the programmers weren't mostly bad, okay? So let's just get that straight. You remember me saying in some witness video that even a single level of inheritance caused performance drops due to memory layout. That is true. In games like The Witness, we just ate that performance problem. There's just certain things that we were not able to do. That's why in the new engine, we don't do it that way. But that's actually an implementation detail of inheritance, right? So inheritance is just the idea that one struct is an extension of another struct and that you can translate between them automatically, let's say, at the compiler level, right? It's not necessarily a statement about how those two structs are stored in memory, right? In C++, it is. In C++, inheritance implies contiguous memory between the parent and the child struct. And in the new language, it doesn't. And that means that you're able to do something like inheritance without taking that performance hit. But yes, when I do inheritance in C++, I am giving up the ability to do certain things, certain kinds of optimizations that would make code faster. Absolutely. What library does the language currently have? We just have a bunch of libraries. You know, we're implementing stuff as we need it. So if I go look at modules, you know, here's all our libraries. Well, some of these are DLLs and stuff, but all the, you know, all these, reflection, sort, Unicode, Windows, X11, you know, hash table. We've got some things in here. We're going to, at some point, organize it a little more because everything is sort of squished into one level. You're in college and all they teach is OOP. What alternatives do you have? The alternatives that you have is just writing procedures and not putting them on objects. If you start doing that, you'll see how things go. That's how everybody programmed before 1988. Not everybody, but most people. How are the modules different from a conventional C++ library? Well, they're all basically source level. They're not a lib. And so you have just as much control over them as you do over your own code. And that also means you can do metaprogram type modifications on that library code no matter what it is. You can compile an optimized version of a function deep in a library to take a certain kind of parameter or take a certain value for one of the parameters, for example, and you can get an optimized version of that out, even if the author of the library, for example, had no idea that you were ever going to do that. You could just do that. That's not the only thing, right? Like you would have to go and be familiar with the metaprogramming facility and the introspection facility to know what that means that you can do that on libraries, but it's very powerful. AOS SOA, sorry, people asked the AOS question several times in the past couple days, and I have answered it several times, so I'm going to skip it right now. Is there going to be any programming today? Good point. Let's get back to programming. We've typed at least like 5 lines of code so far. Okay, so we expand the match status. We have number of argument polymorph statuses. And then, well, let's just make sure that compiles. It's not going to compile because isActive is still trying to be used. Right. So we gotta fix that. So now we're just using the pointers. If these pointers are live, we are matching. Okay, old matching wanted. Here is the thing that we just did a few streams ago, where we turned the active flag off for a while to disable matching. We still want to do that. We just want to do it by caching the pointer, setting it to null, recursing, and then doing the same thing for the given down here. Wow, I sure want to know if I'm polymatching all the time. Okay. I bet there's some people in other files setting isActive. Maybe not. Maybe we call start polymatching. Start variable matching. Okay. This is one of those things that probably has to change a little bit. Okay. You know, sometimes we get into long Q&A sessions. It's fine. Some people want programming. Some people want to ask questions. You know, it's all good. Okay. So the thing is, there's 2 sets of match statuses, right? There's the match status for the argument, like if we're calling a procedure, there's a match status for the procedure we're calling, which is the one that we need for this test case that we put together. But there's also, you know, you could be passing a polymorphic object in, and so that's the given match status. And I guess none of that changes, except well, I don't know. Does start variable matching do anything else? Well, we set the is active. We reset the matches. Yeah, all that is bogus bunkum. Because we're going to construct a new one of these each time now. Okay. So what I'm wondering is if I need to do, like, do I need my start variable matching to say something specific about whether we're starting for wanted or given? I don't think so. It's just I haven't thought this through. So in polymorph, when we're passing a polymorphic argument, we do both. But we don't need to do anything special for either one. Okay, I'm gonna assume that we can do it this way. And if we have a problem, we will have a problem. So I'm actually gonna just do this. And what was it called? Make match status. Now, I could just have this return a thing, but if I return a thing, then I for sure don't know if we're starting for wanted or given. But here, if I wanted to temporarily know, I could do a hack where I test this address to see if it's the address of wanted or the address of given. So I'm leaving myself that option. Normally, you would just return this result instead of assigning it to the pointer. We don't need to do that, right? Because this is starting false, or this is starting false. This has a constructor. We're all good. Except our typer new still isn't going to work. We're going to have to do something there. Okay. So stop variable matching. Let's call this status pointer. Okay. Well, we don't do anything with that. We just say star status pointer equals null. Boom. Okay, down here, because I know this is going to be a problem, get memory. Okay. So here we're going to say no, that doesn't run the constructor. I wish this memory were simpler. Okay, no, typer new is fine. Never mind. I was wrong. when I said that wouldn't work. All right, let's just see what happens now. We have fewer errors. Only 2 files are really complaining. Okay. So this is going to be annoying. This is the stupid part of C++, changing all your dots to arrows. And in some cases, we might have crashes now because we might have been assuming, you know, we know that the thing's there and we know we can dot it, whereas now that's not necessarily true. Okay. Check for duplicates. Really? A typer new is only on an ast. So stupid. All right. I need to go clean these up at some point. But it's just dumb to have this many variants of things. I think I don't have to do that. New paren, get memory paren. There's one too many parens. Except put it around that. Right, and then okay, so that's done. Typer 1808. Okay, check for yield. Well, and polymorph. This is so dumb. C++. We love changing our dots to arrows. It's such a productive use of programmer time. Check for duplicates. Maybe add match. Okay. Great. Now, did maybe add match? Did this used to check the active flag? If it did, we need to do something. I don't think I would have just deleted it, but it could have been a mistake. Let's check for that mistake. Wait, why? All right. Maybe add match. Nope. Okay. It's fine. How long have I been using the eye tracker? Just a few days. I don't know if it's something I would recommend. Some people think it's annoying. Some people think it's good. I would like to do an enhanced display for it that's better for viewing code, but I don't know when I'm going to have the time to do that. I'm probably not going to do it in Emacs because you don't need this little dot darting around. You just kind of need to know what lines am I looking at right now. And I think if we displayed that, that would be much neater. But you need editor integration for that, and I'm not, N-O-T, not going to do that in Emacs. Okay, well, that test doesn't work, which is, we knew that. But now let's try commenting out the non-working stuff. Oh, okay. Well, we should not be crashing, so we introduced a new problem. Do I need to take the drinks out of the freezer? I've been thinking about it in the back of my mind, but I think they need a little more time. How much more work would a text editor be compared with a jot-down console? It depends on what you want your text editor to do. You know what I'm saying? Oh, we've got more isActives because they're in asserts. All right. Error argument polymorph status. Status is. Okay. Okay. We are running bug 174 test. It's not really bug 174. We just used that folder because we were already nearby. Okay, why does it crash? I bet it's because we're dotting something and assuming. Check for duplicates. Status. Oh, because stop variable matching. Okay, so this is the thing. So before, when we said stop matching, our result would hang around and we could look at it because it wouldn't reset till we called start. Now we set it to null. I don't know if that was a good idea, but it's going to force us to do some things. So anytime we call stop variable matching, we need to get the result. And so why don't we make it return the old value? I mean, it's kind of dumb because we're passing it in as an argument, but whatever. This is a little precarious because if we accidentally, if we accidentally use the old variable, that's no good. Okay, so okay. So you've already got a variable here called result. Now here's the thing. We don't need to do this. So I'm going to write down on the to-do list, solutions wanted, or solutions return doesn't need a copy, colon, no copy, which will help me find it. Okay. But I'm not going to mess with that yet because we want to get all this working. Although, no, I should. Okay, I have to. Never mind. Because the solutions return assumes it's a one-level structure. Like we're copying the matches out of the first level, but we're ignoring the hierarchical info. So like that. Much simpler. Now, because this is C++, I can't just do what I did. You've got to ask the compiler pretty please for permission to do that. And then whoever calls this now has to change. Okay. Glad you guys are still talking about Java. It's really the programming language of the future there. Okay, solve for matches non-looping. We knew that. Solve for matches non-looping. Solutions return. Oh, it passes it up. Oh, we got to do it again. So here we're doing the same thing where we're copying stuff. Okay, so we're doing this matches wanted and matches given. What are those all about? This is going to have to change. Move matches into constants block. Yeah, this is gonna not really work very well. We're going to want to move this out of this routine. I was hoping that we could get back to a working program without doing this, but sometimes you start pulling on the thread and you just keep pulling on the thread. You know what I'm saying? So I think that what we really the looping case is gonna be gnarly. Okay, we are going to comment out the entire loop solver case until later. Loop solver is only only necessary when you pass a polymorphic argument, which we're not even testing yet. And we're just going to say assert false right here, because the thing is about the loop solver is you can't just return a tidy result and say, hey, polymorph this stuff. Because you have to incrementally introduce all the values. Maybe I'll come up with a different way of doing that that doesn't require so much bookkeeping, but in the meantime, we're just gonna party on down to Funky Town here. So that's going to be fun, making that work later. Okay, so we solve for matches. Auto value bake. Yeah. This is where we start interfacing with other features and it gets weird, I think. I'm just gonna do this. Of course, polymorphing is going to have to change. All this stuff where we, like, this is going to all have to change, but it'll change for the better. I just want to get back to a running program for a second. Well, we didn't crash. I don't know if we actually compiled the program. Let's see. Let's see. Whoops. Okay. Okay, so we have a working program again. That's good. And basic polymorphism still works. This is one of the few cases where I would be greatly relieved if I had a source control system that let me check in locally, because I would check in a copy of the source. I can't check it into the global repository because I will break the compiler for everyone. But this is good. So I'm gonna heat up some tea with caffeine. Let's stay to very brief, because I did a lot of Q&A earlier. Very brief on-topic technical questions about what exactly is going on right now. If you have those, put them in the chat, and I'll answer them while the tea is cooking. Asking about debugger IDE are not on topic for this stream. Do I have a favorite video game is not on topic for this stream. Well, on topic about the current polymorphism task. Recommending books is not on topic. Sorry. All these are off topic. Nobody... What's on topic is technical questions about the code that is being typed in right now. The actual computer program that is being typed in right now. Yeah. We're not really throwing away any principles about polymorphism. When we're done here, it'll work exactly the same as it did before, except maybe more robustly in weird corner cases. We're purely changing the internal implementation to be something that'll work better and hopefully be faster and complicate the compiler less. Did we consider transforming the AST to another form that's more conducive to type inference function narrowing? I don't know what form would be more conducive. You'd have to be more specific because as far as I can tell, it doesn't matter. Well, you could say that the previous thing that I had done that was too complicated was an example of manipulating the AST into something that I thought at the time was more conducive to polymorphism. But I think now that I thought wrong back then. Is there a limit on how complicated polymorphism can get? In principle, no. If we find a limit that's not just like the compiler running out of memory or something, then we will address that. But no, like you should be able to have an arbitrarily deep nesting of polymorphic expressions, and as long as it's solvable, it should get solved. Is G::A irrelevant to B to C, $B to C valid? Yes. I mean, if I understand, that should be totally fine. I mean, I assume A, B, and C are well-defined types like int or something because they don't have $signs. Or no, not B. B has a $sign, but A and C. So I guess what you're saying is the fact that you use B before it gets matched, is that valid? And the answer is yes. Most of the questions are off topic, so we're just going to soldier ahead. So what happens in that case when you use B and then define it later? We actually do all this in two phases. The first phase is just finding the definitions. So if we're checking that types match and you use a polymorphic variable somewhere, we just say, okay, it matches. We don't care because we're going to check it for real later on when we know what all the types are, right? So we find out what all the types are and then we check it for real, which is when we check that use of B. But prior to that, the use of B is essentially a no-op. Can you pass a lambda function that has a default parameter? Yes, of course. Yes. Can you pass a function like that without a parameter for the function being named? What? I don't understand. You have... It looks like, I mean, procedures, yeah, you wouldn't put the colon, right? So I think you're saying that the first parameter to G doesn't have a name. That's fine. It would be like C or C++ where you just say the type in there. Yes, you could do that. Okay, I'm still ignoring the off-topic questions. Still ignoring them. So many off-topic questions. Let's do some more programming. Programming. Okay. The next step is there are sort of two major steps now to do. We've made our data representation. It wasn't a very complicated one, but we made it. Now, when we are matching, we need to generate the hierarchical version because we're not doing that yet. And then after we match, we need to use the hierarchical version to generate the output procedure. I think the first one is a smaller structural change than the second one. I'm not completely sure, but I'm going to start with the first one. And again, I want to end up with a running program that still runs this test. And I want to be able to set a breakpoint and see that we have properly generated the data structure with multiple levels for this thing in test, right? So this thing, when I put this back, in fact, we can leave that. It'll compile with the oh no, it won't. Okay. So we want to get to the point where, I think it's saying this because when we steal polymorphism before, we used to take the flag off the procedure. And now that's not true. So anyway, I think we'll be taking this error message out. But the point is, we want this to be able to now compile, as long as we don't call this yet, because calling it means using the hierarchical data, but we should generate the hierarchical data correctly. Okay. That's all good. So let's do it. Well, let me wait. I'm going to wait another 10 seconds for my T to steep. So that it doesn't oversteep, because that'll put me in deep trouble. We are not going to release an official fact soon, but I think I might get Abner to release his annotations. In fact, I'm making a note to email him about that. Okay. Okay. Let's do the thing. So when we're in check that types match and we're matching a procedure, then yeah. Then if the procedure is polymorphic, we need to push the thing. We need to push the thing. Okay. Check that types match. So where is the lambda handling? So structs, strings, strings, numbers, pointers to things. Wow, our pointer handling has a lot of code now. Wait, more structs? What? Oh, incompletely specialized structs. Okay, whatever. And then general structs. Lambdas. Okay. So we check the returns first. It's weird. And okay. So we need to push either wanted or given. We only need to push wanted for this example to work, but I'm going to put in both because that. Does the language have parameter list as a type? No. And does it have currying? Not in the way functional languages do, but we have a thing called argument bake that essentially can boil a procedure down to a procedure with fewer arguments. So it's essentially currying, it's just different. Of course you're supposed to understand the code showing here. Don't set low expectations for yourself. That's not how you succeed in life. All right. So I'm going to make a tag called given incomplete. Because again, that's only necessary for harder cases that we don't have yet. I'm going to do that because the code that I'm doing for matching still may be conceptually unsound in some way, and we're going to find out if it really works through doing this. And then if it really works, I'll do the same thing for given. Okay, so if poly matching wanted, then if wanted defin flags and type definition is polymorphic, then we may well be doing variable matching. However, incomplete, I'm going to put another tag here, polymorph specificity. We actually don't need to push a new level if it's only polymorph use, just if there are polymorph defines. So probably we should have a separate flag for polymorph defines, but it gets carried along with polymorphic. Okay. Polymorph define flag. Okay. So if we're matching and it's polymorphic, then old status wanted poly matching wanted. And then poly matching wanted equals new status wanted, which we'll define in a minute. And then down here, so before we return, we're going to use a defer. Defer if old status wanted poly matching wanted equals old status wanted, right? So no matter which return we do, we will revert this to the previous thinger. Well, what's new status wanted? Well, so first of all, we need to expand the thing. So new status wanted is make match status if not poly matching wanted arrow argument polymorph statuses expand match status. This is in polymorph. Expand match status of okay, int num arguments equals wanted lambda return declarations.items plus wanted lambda argument declarations.items. So let's put the arguments before the returns, because that's how we're going to order them in the data, and there's no need to be confusing about these things. Okay, so we've got some arguments. We need that many sub things. We've got a new thing. Now we need to put the new thing in the slot according to now is where it gets confusing. We actually want to do this stuff, not yet. We want to do it when we know in which sub-argument we may need this. So we're going to factor all this out into a procedure. Blech. Blech, I say. Blech. Because we need our old status wanted to be out here. This is one of those things that's a little more annoying than I want. Okay, so if we're polymorphic, old status wanted gets saved. That's fine. If we never change it and it gets changed back, who cares? That's fine. Now, when we do an argument or a return value, before we call check that types match, for example, right here where I'm looking, if the eye tracker is accurate. Right before that, in that gap, we want to say if this argument is polymorphic, or this return declaration is polymorphic, then do the thing. Now, we don't have to do this for return values yet because our test case doesn't have return values. So I'm going to say returns incomplete. And we're just going to do it for arguments. SME. Same thing here for return values. So I've written on my piece of paper to come pay attention to that. Okay. Now this, when we're doing arguments, before we call check that types match, here, we want to say if we're matching and type wanted defin flags and type definition is polymorphic. Actually, we don't need the defer. We don't need all that stuff. No, okay. We're not going to do this way. We're going to see, we're discovering what we need to do here. It's all good. So, when we're type checking a lambda, before we descend into each argument, we're going to do this. And I don't think we need the defer because we're going to just restore it normally because we don't return. Okay. I mean, we'll just set this down here. Screw it. The only reason we did this separately was because of the defer. So, if we don't have statuses, then we do this. No, I'm not doing this right. I am not doing this right. Okay, here's the thing that makes it complicated. The thing that we care about actually is not whether the argument is polymorphic, because it could be like a pointer to a polymorphic use or whatever, who cares? What we care about is if the argument, this is why I did this other thing before. What we care about is when we cross the border into something else, which we won't be able to know from here, because it could be a pointer to a procedure or a pointer to a struct in the argument. So we have to recurse before we know what we're targeting. Too close to the microphone. Okay, I'll move the microphone away so that it's not so easy. Let me move it back. Okay, there we go. So, well, that was why before I had this index that says current argument index, because I knew this before, I just forgot it. So what we're really going to do in this loop is we're going to set current argument index. And that's it. And then when we compare two lambdas, then if current argument index is not equal to -1, then we do this depth increase situation. So yes, I'm making a mess here by moving all this stuff around, but it's all for a good cause. Okay, we're going to cut this out for a second. Actually, all this. Whoops. Emacs, come back. So that's all going over there for a second. And then here, I'm going to say if poly matching wanted poly matching wanted arrow, whatever that was called, argument, current argument index, I'm going to guess, equals this might be slightly wrong. I don't know. We're gonna find out. Okay. Then where we want all this stuff to be is as soon as we realize it's a lambda, which is pretty close. It's just up here again. So, and actually, okay, it's a lambda. Well, it's basically here. It's just we do it slightly different. Okay. Maybe I kind of knew what I was doing. So here we say, if we're polymorphic, do we care if we're polymorphic? Yes, I guess we do. So if we're polymorphic, then if the argument index is -1, then we're at top level and we don't need to do anything. So if poly matching wanted and we're polymorphic, okay, well, if current argument index, this might be the wrong name, but basically if we've recursed, if this isn't the original function that was called at the top level, okay, then let's copy this comment because this is correct. So if the argument is greater than or equal to 0, we do that. We do this. We do our defer just like before. Okay. So, well, we've got our old status wanted. We've got our new status wanted. And we just do this, right? Like all this stuff that I was doing. Well, here, but not, this is wrong. This number of arguments is wrong. So in addition to setting current argument index, we need that to be stored because we don't have it anymore. We're like on the argument of the lambda and we can't see the outer lambda. So that information needs to have been given to us previously, which means we need to go into polymorph and say, whoops. So we can, I just pasted that because I'm messing with my cut buffer right now. We can assert this is greater than or equal to, it's greater than 0. If it were 0, we should not be here. And then when we set the current argument index, this is a redundant computation because we're doing it every time, but whatever. Whatever. Okay. So we're doing that. We're doing this. I'm very happy with how not complicated this is, but it could be wrong. Okay. Building. I thought it was poly matching. Is it called polymorph matching? What's it? Polymorph.polymatching wanted. Great. What a pain in the butt. What a great idea of me to put that on a separate place. You thought today would be type inference optimization. Yeah, I was thinking about that too, and then I changed my mind. I decided to do this first because both systems are complicated and a little scary, but this one is more complicated and more scary. And if I do this and make it less scary, then type inference gets less scary. And so optimization of that will go more smoothly. So I just, I slept on it. I felt better about working on this. Is the defer wrong now too? No, I don't believe that it is. Might be. Might be wrong, but I don't think so. Okay, well, we got a program that compiles. Okay, polymorphic procedure must have a body. That's fine. So first step is to make sure that we don't do less than we did before, which is a distinct possibility. So test. Okay, we don't do less than we did before. That's great. I mean, that would be a good motto for all programmers, right? If you could just not do less than you did before, the web would be much better than it is today. Software wouldn't be as awful across the board. Yeah. Okay. Now, I suspect in order to test this thinger that we just did, I suspect that I need to go and fix that error message, because this is probably happening first. And it's no longer true. So let's uncomment this so that we get that again. But when we uncomment that, we want to make sure that certain things are still outlawed. So for example, you can't have a declaration of like a polymorphic procedure type, right? So you can't say apply is a pointer to this, like, or something, right? We don't want it to be apply. So or actually, even forgetting that, we don't want some proc that's exactly like apply. Let's just do this. We don't want that, and we especially don't want that. These things are not legal. I need to use a identifier. CRT. Okay, so none of those should work. But we don't get to them right now. Oh, we do. Okay, this is a different error. So that's fine. Must have a body. Line 4882. I mean, I think we just get rid of this. Well, let's comment it out in case we need to do a more sophisticated check there. God, Visual Studio is so slow at compiling. Undeclared identifier CRT. Okay, but that's fine. We'll just do this. Undeclared identifier T. Well, that's not exactly the error that I would have preferred. But I'm actually okay with it, right? Because that falls under make the error messages better. Yeah. So what's happening is because we never call this as a procedure, Oh no, guys. There's a fatal flaw in my plan that I'm not sure how to solve. Nobody ever brought it up. There is a fatal flaw. There is a fatal flaw. Something should not work because it's polymorphic. Like, there's no such thing. A pointer is data, and there's no such thing as data that's polymorphic. Okay, there's a fatal flaw in everything that I've been doing here. I told you this might happen at the start of the stream, or at the start of last stream even, maybe this stream. The problem is the following. Everything that I've been doing has been about poking this identifier down into this procedure. What I haven't thought about yet is the fact that this is trying to refer to that, right? So T actually the actual variables do need, we may need to bring that steel back, because the actual variables do need to be declared at a scope that's the parent of all these guys. And you need to be able to use this T in the body, right? So T needs to be in the constants block of apply. I mean, I assume all this hierarchical stuff that I'm doing is still good. It's just that what it needs to do is once we have solved for T, I mean, maybe all this stuff that I'm doing only makes sense for auto-poly structs, because those are the ones where you don't write the declaration. Maybe my whole life is a lie and none of this is ever going to work. So it's funny how I can just like not, like that's the whole point of polymorphic variables, but I wasn't thinking about it when I started doing this. It's funny how easy that is to do. So when the quick synopsis is that everything is terrible right now. That is the quick synopsis. Everything, programming is really bad. That's the synopsis. It's like when you say $T in a declaration like that, it's because you really want to use T in the top level function. Like You can't use it that much. You could only use it here, for example, but in general, you want to use it outside. So if I restrict it to that scope, I'm really not being helpful. So T really does want to live in the outer block. Actually, that doesn't necessarily change much, if we're being honest. So it doesn't ruin anything, actually. So that's good. Because I could always, you know, as I make these hierarchical thingamaboppers, I can always just keep a pointer back to the original one, and the original one gets those things. The two complicated cases are the loop solver and the autopoly structs. You know what? I think I might wipe this whole thing that we've been doing all today. I might. I think it might be the wrong road, because no matter what changes I make, if the variables have to live in the outer scope, then you always have to make something that says, oh, this inner variable refers to the outer variable, right? And that was one of the things I was complaining about in the autopoly structs, was that I thought that was complicated. And it is. It's complicated, and it makes my life annoying. But if there's no way around it, like if you just functionally have to do that because that's what the problem requires, then it would be better for me to take a different approach. Such as, for example, maybe we're going to copy for polymorph all the time, but maybe we do that thing I was talking about where the types of each node is stored in a different place than the nodes themselves. And if I did that, okay, if I did that, the best way to do that is to have things be flattened. And if the best way to do the compiler is to have things be flattened, then I shouldn't do the change away from flattening that I was talking about yesterday. See, it's hard to know what to do. It's hard to know what to do. Like if part of my objection with polymorphing is that I'm just copying stuff all the time, I could move to a compiler architecture where we don't copy things as much. The problem is a lot of things have to change because you can't. That's a big change, man. So I'm not sure what to do. I have a feeling that I'm not going to do any more programming here before the break. I think I'm just going to stare at this for a little bit and try to understand more clearly the situation. And then maybe I'll take a break and think about what I'm going to do. And then maybe I'll come back and just dramatically revert everything we did for 4 hours today. Or something like that. Is it likely that the solution will come to you when you're doing something completely different? Maybe, but it's possible that there is no solution. It's possible that anything that I do is isomorphic to what I'm doing now. I would like it if that were not true, but I'm not sure. It just seems really messy and heavyweight to be copying things all the time as I do. Like if an autopoly for a struct, so, you know, like let's do an autopoly version of one of these. It's just, you know, it doesn't make any sense anymore, but like if I had a string bucket, right, and that's a polymorphic struct, then the thing is right now I actually copy the body of string bucket, which is arbitrarily big. And that's kind of gross, which is one of the reasons why I wanted to get away from this. And the reason I copy it, well, is because I need to be able to do this, right? But where you're not going to refer to A and B directly in the code because you didn't give a name, right? But you might say, you know, you might say type of A dot, you know, element type or element, whatever. You might refer to types that way, but you're not going to say $A, or you're not going to say A, capital A, because capital A doesn't exist by any name that you can refer to. So when we do the autopoly version of that is when you don't write those parameters. Okay, now when you don't write those parameters, we, like I was saying in the first stream today, we have to make a new copy of string bucket that has a constants block where A and B are defined. And we do in general need to do that because here's the thing. You could have like string bucket is a struct, A is a type, and B is a type. I don't know, right? Let's name those some A and some B to make clear that these names are not the same as the A and B below, right? So you could say X is an array of 10 sum A and Y is a pointer to sum B. And then you could have, you know, T be type of X, right? And then this is actually legal to write because we're trying to be a powerful language. You could say foo is an expandable array of type of A dot, or of not even, we can say A dot T, right? So, you know, the solving process needs to know, like, okay, whatever string bucket you pass, well, we know A and B, so we know the types of all of these, right? So T is the type of X. That's great. And so a dot t here, now we know that it's this, right? We need to be able to do all of that. And you can't really do this in the general case without copying the struct. So as unhappy as I am, or without re-inferring the struct, right? Maybe, as I said before, we could restructure the whole compiler so we don't need to copy it. So as unhappy as I am about copying the struct, like I was about to do all this stuff to try to avoid that. I don't think it can be avoided, right? And this is one of those things I was saying. I said I gave a warning at the start of this stream. Maybe I'm going to find that what I'm doing is fundamentally unsound. And I think that I have discovered that. I think in the past 5 minutes, by explaining this, I just convinced myself of that. And I think I knew this before, I just never wrote it down in a place that I could refer to it again, because it's what I learned in the process of building this part of the compiler, and then I forgot all about it. So maybe really what I should do is document this. How much do these big changes become impossible or really hard once the compiler is released? They don't. I mean, we would try to preserve semantics for people, but we're trying to do that now, right? We're not trying to change what's legal. We're just trying to make the implementation better. I think I'm going to have to revert all this and document why we need to do this stuff and chalk it up as a learning experience. And it would be a very good learning experience because it also means maybe I shouldn't go ahead getting rid of flattening, because I want to think about that. There's another problem, like the way that we do substitutions kind of sucks. So maybe if I separate out substitutions, maybe fixing substitution is the best new big thing that I need to do. That's a whole separate issue we could talk about. Anyway, compilers are hard. They're hard. It's a lot to keep in your head, and it's easy to mess up, and I think I messed up today. I think what I'm trying to do just doesn't make sense. Unless someone's paying enough attention that they can explain to me why it does make sense, and I'm wrong that it doesn't. I just dropped some frames. Frickin' Comcast. Jerks. What you said about it not making sense makes sense. Yes, I used my slideshow program for the talk in China. Yeah, people, I don't think I can avoid this. Like, I think maybe someday I could make a fast path for like not in copying this struct and doing all this if you know, we're not in some kind of hard case like this one where we need to do crazy stuff. But I don't think I can do what I'm trying to do. I don't think it will work. I think it fundamentally doesn't make sense. Is it maybe possible that you let the programmer annotate whether to copy or not? Well, I mean, you might be able to do that as a speed of compilation thing, but I can't see a way in which that's useful. And the compiler has to not break if it needs to copy, right? And that's the thing, is it's supporting the functionality that's that complicated that is kind of what bugs me. Like, I'm trying to simplify the core of the compiler, right? An optional markup isn't gonna let me be more simple. Are we on the new tiered internet program? No. Not yet. Okay, well, I'm going to not do anything drastic now. I'm going to take a break, and I'm just going to keep thinking about this. But the next stream today may start with me just reverting everything. And then thinking about substitution, because that's one of the arms of the compiler that I would like to be better than it is. And the way that I do substitution right now is one of the things forcing copies in some cases. Like, if I can reduce the amount by which I force things to be copied, then maybe some of this stuff is not so bad. Although the copier, you know, we profiled the copier and it didn't take that long. I don't know. It's just the complexity. How did you get the passion for programming? Because it's really difficult for me when I see so many flaws with its design and ideas. Well, I just was excited about it since I was a little kid. Like, there was just something cool about typing in some stuff and it makes the computer go. Like, I just really like that. And of course, what you learn very soon after that is sometimes it's very hard to make the computer do what you wanted it to do. But that's just something that you got to stick through. And the better you are at programming, the less that happens. So today I had an instance of that, like, oh, what a bummer. I mean, this would have all gone much faster if I wasn't streaming and trying to explain it. But it was like, oh, this thing that I've been doing for a few hours really is not the right thing at all. And I was so hopeful about it because I was like, this is going to be amazing and simplify everything. When in fact, it's really not. So, well, yeah. Yeah, I don't know. I'll think about it a little bit during the break, but I think there's no way for me to get out of copying all this stuff. I think it's just fundamental. Isn't reverting everything easy? Yeah, it's super easy. It's super easy to revert. It's just, you know, I only want to do that if I am sure I don't want to go in this direction anymore. Yeah, so, you know, having adversity like this is part of the process. But once I feel out ways that I can simplify things, in fact, you know, we did that over the past couple of days. We simplified some stuff and it felt really good. And I was much happier with the compiler. And then now here I've got a roadblock, but it's like, okay, it's not that much of a setback. We're just back where we were last night. And things were pretty good last night. So, and then once I do find out the next thing that I can wiggle and make better, that'll feel really good too. So, you know, sometimes this is just what the job is. Sometimes you have this kind of a problem. If I were smarter than I currently am, or if the program was simpler so I could see it more clearly. So maybe if I had simplified other things first, or if I had spent more time with the system and knew it more thoroughly, because even though I programmed almost the whole thing, it's complicated enough that it doesn't all sit in my head at once. If any of those things were true, I might have known ahead of time just not to try and do this, but I didn't. And this is what happens, you know, but it's just fine. It maybe makes for a less entertaining stream because we don't get concrete results, but this is programming. I'm sure this has happened in Handmade Hero sometimes, right? Like there have to have been, because he doesn't do that much in one episode. So, because they're only like an hour, or now the weekend ones are a couple hours. So I'm sure he spent several episodes on something and said, you know what, let's backtrack and delete all that. It's just part of what the job is. Casey always programs perfectly. Maybe that's true. All right. Me and my cough drop are going to take a break. And yeah, he did a bunch of work figuring out Z ordering in 2D and then decided to make it 3D. Yeah. No, that's programming, man. That's part of what happens. Yeah, so I'm going to take a break. You know what? I am very close to 100% confident that I need to revert. So what I'm actually going to do so that we get closure on this stream is I'm just going to copy my source folder to just like a backup here. So it's here. I'm not going to put it in source control, but I can come back to this point if I want to. And now we're just going to revert because we want closure on this process. Ba-boom. And build. Let's do a full rebuild. Yeah, this is why the UML or like the waterfall model of programming don't work that well. Like people say, well, you should plan out things very carefully. And one thing is, well, it's very hard and probably impossible to plan things out beyond a certain point. Okay, Sokoban works. And the second thing is, if you haven't worked on the project that much, you're not an expert. As I say before, you're not the right person to plan it out. Did that all happen that fast? I guess so. Oh wait, CL, oh, I didn't run vars. I need to fix that script, not change the folder. All right, so things are still working. So we're back where we were late last night when I went to bed, and I've had a learning experience, and that's fine. We're back at 41562 lines. I did, while doing that, notice, okay, let's at least make one small progress. And this is not even going to show up in the line count because it's in the libraries. But remember, for those of you who have been watching this stream, I noticed this thing called type info cast. This used to be used because when you would say like type info of X, that would always yield something that was a pointer to type info. But that's not how it works anymore. Now it actually gives you a type info struct or a type info pointer or whatever the most specific one is, right? And because we have inheritance, you don't need to know that. So you could say t:type info equals, and it'll downcast that, right? So it's all good. So I think probably nobody uses type info cast, and we could just delete it. Or if someone does, maybe they don't need to. So I want to do a little bit of progress before the break. It's in vars. So we certainly don't need it in the preload. So now let's look at Sinsokoban. I don't think we need it there either, but print enums as their internal type. Oh, no, we actually use that here. This is a legit use of this thing, but like, let's just, if it's part of Sokoban, let's just frickin' put it in Sokoban. I feel like somebody else put this in preload and not me, because this spacing is not how I would do it. I wonder if someone else uses that. Maybe we should put it in basic. So Sokoban builds. Yeah. Yeah, that should just not be in preload. So great. Progress. Now, because preload is smaller, every single thing that compiles needs to compile one procedure less. In fact, if you have a metaprogram, at least 2 procedures less, because we load the preload for every workspace. So remove type info cast out of preload. Only stuff that is absolutely necessary for the compiler to run should be in preload. Okay. That's progress. Now we are further along toward a better compiler than we were last night when I went to bed. So now we're going to take a break and document while it's still fresh in my mind. Maybe, you know, I think maybe I'll just put a link to the stream as documentation, because I could type out all the reasoning that I had, but I'd rather just put a small note that says, by the way, you can't do X because of this. And I'll just link to the YouTube video. So I'll do that once I put this on YouTube, which will be, you know, later tonight or tomorrow. All right. So I'm going to take a break. Thank you, everybody, for coming by. And I'm going to stream again today after the break, maybe even 2 more streams. I don't know what we're going to work on. We're going to be still trying to make the compiler better. I want to think about that substitution thing. So maybe I'll talk through what the hell I'm talking about when I say substitution and why it's a problem. Yeah. Etc. I may want to drastically restructure the compiler. I don't know. I don't know. All right. See y'all later.